Hello, we're back. And in this third video lecture, which it will be relatively short, we'll talk more about EHR systems and get into a little bit more of the weeds about databases. And again, I think we left off here talking about data governance and versus information governance. Basically, it has to be governed, right? Both at the data level, where we're looking at things that are coming in without context, and also in the context of information. And we talked about accountability, transparency, integrity, protection, compliance, availability, retention, disposition, the information systems life cycle, which you've probably seen before. And now we get into the nitty gritty about what a database management system is. And basically, we're talking about, for the purposes of this course, a relational database. In other words, a collection of fields that are tied together to create essentially an electronic filing cabinet full of data and information. And the data has to be defined in a data dictionary. And sometimes people get lost on the concept of a data dictionary, but basically it's rules for managing your data. So the simplest example of that would be dates. We could say it's October 31st and spell out OCTOBER 31, comma, and the year. We could put 10/31 and then 2 characters for the year or 4 characters for the year. As long as people know what you're talking about, many of you think it probably doesn't matter, and you're correct. But a data dictionary is putting those rules in place where you say that the date will be displayed in a 2 character month, slash 2 character day of the month, slash, and 4 characters for the year. So that's what a data dictionary does. It's puts those standardized definitions, those rules, if you will, into place. And so if we have a database, we have to be able to manage it. We need to update data. We need to modify data, delete data, view information. And that's the concept of database management. And the information from these different systems needs to be stored in an electronic format in a clinical data repository. If we have images from radiology, they're typically stored in a PACS system, right? And there are other systems that store things for pharmacy, narrative notes, and so on. They all go into the clinical data repository. And then, of course, we store the data in a data warehouse. Some places like Kaiser Permanente will have a data warehouse where there'll be de-identified information that gets uploaded between several different regions. And then people, when they're doing research or quality utilization or what have you, they can query that and come to some high-level conclusions. And again, a subset of the data warehouse is a data mart. So if we just wanted to look at pharmacy data amongst all the Kaiser regions and just pharmacy information, that's an example of a data mart. Data has to be managed and retrieved using these different software. And one that you'll get introduced to in HAM 125 relates to the last bullet point, that's structured query language. And that's how you can run reports. And you could say, run different commands and query, in other words, ask the database a question, how many of our patients have United Healthcare as a payer, for instance? When we talk about relational databases, we're talking about tables being these spreadsheet-like things that store information in records and fields. Kind of think of records as things going across that relate to one patient, and fields being in columns that relate to everybody, an MRN, a date of birth, and so on, right? And we create these tables by using definition language, data definition language. And again, as society continues to use data to treat patients, do research, manage healthcare, all these different things, we'll see HIM professionals play an even more important role in managing this data and information. As these new systems emerge, we'll see new companies, as we talked about in the announcement this week. We'll talk about all these new things, but the same kind of concepts will remain. We'll still have records and fields. We'll still have interoperability challenges and so on. Artificial intelligent applications will help patients manage disease more effectively by providing alerts, right? However, artificial intelligence basically allows us to do things quicker and more accurate. It doesn't make decisions about what's appropriate. It doesn't write and decide the policies and procedures, whether they're appropriate or not. It basically is just another tool, right? So it's essential that all these emerging technologies are developed in a manner that promotes interoperability. You can have the best electronic health record system, but no organization is an island. So you have to be able to share information with the VA if you work for Kaiser, or Sutter has to share things with CMS. And that's where interoperability becomes even more of an issue when you're talking about CMS and other payers.